Welcome everyone to this session on certification. It's something we're very excited about at I/O. But maybe I should start by saying what we're certifying for. What does certification mean? I think if you dig down a bit deeper, what we're trying to do is provide for dApps that are on Cardano and the smart contracts that go into those some degree of assurance that they have good properties and don't have bad properties, and some degree of audit. So ensuring that they've been produced in a way that complies with the best practice that we see around the industry. And what we've thought about, the way we've conceived this, is to have 3 different levels of certification. Levels 1, 2, and 3. But I think it's important to realize that when we talk about those levels, they're not so much progressive as complementary. They address really 3 different dimensions of assurance and audit. So level 1 is about providing automated tooling that gives continual assurance about a range of properties for smart contracts. And the great thing about automated tooling is it can be applied repeatedly, it can be applied automatically. So each time there's a new release or a sub-release of an app, we can test the contracts inside it again to ensure that they still have the properties we wish them to have. And that's accessible to everyone. It's low cost, low effort, but providing a substantial amount of assurance. At the next level, we have something in an almost different direction, which is in-depth audit. So that's looking at the technology, but it's looking at the processes that led to that technology being produced. Looking at what testing there's been, how the app meets any spec there is for it, how well tested it is, other software development processes. And that's a much more in-depth and manual process. It may have some automated testing and so on built into it, but it involves deeper manual effort. But a crucial point about that, in distinction to level 1, that can address a whole dApp, not simply smart contracts, but a dApp written in both contract language and other languages such as JavaScript. The whole dApp can be assessed. Then moving on to level 2, we're looking again at something more specialized, but an area where we aim to provide full assurance of critical aspects of applications, again through formal verification of smart contracts. So we address smart contracts, we address full dApps, we do automated tooling, machine-assisted proof, and manual processes to perform audit. And in doing this, it won't be I/O that will be doing the auditing or testing. We have a strong ecosystem of partners, Runtime Verification, CertiK, Well-Typed, Tweag, and QuviQ, all of whom have representatives here. And what's more, we've got a first customer coming in looking for this, that RV will be, and potentially other of our certifying partners, will be looking at certifying the Sunday swap application. I think in the longer term, what we want to do is build support from the industry for emerging standards of certification. We want to work with our partners and others, aiming to articulate best practice for certification. And this may involve, in the future, working with the Cardano Foundation or forming an industry body that can act as an umbrella organization for these sorts of activities. And finally, it's worth being aware that we plan to integrate this certification with a dApp store that we're building, so that we can provide cryptographically secure non-fungible tokens, for example, that give evidence or point to evidence of certain levels of certification. So people can't fake the certification that we're guaranteeing. I mean, I think there are technical challenges that will come out of this. We'll have to think about how we support versions of dApps. We'll have to think about how we package dApps up in order to make them available to automated tooling and so on. So there'll be a lot of things we'll want to think about in the longer term, but we're very excited about moving forward with this, with the community and with the partners who we have here. But now what we'll do is turn over to Jean-Frédéric Etienne, who's going to talk in a bit more depth about what we're doing for audit.
Hi everyone, I'm Jean-Frédéric Etienne, former method software engineer at UTXO. In this talk, I will briefly present the level 2 audit certification requirements. The level 2 requirements mainly focus on the methodologies and processes to be followed by both developers and auditors of the apps, with the objective to ensure a high level of assurance in terms of consistency, correctness, and completeness of requirements, compliance of implementation with requirements, compliance of implementation with any high-level properties to ensure the absence of common security vulnerabilities, and assurance in terms of robustness, reliability, and maintainability of the app to be deployed on the Cardano ecosystem. So note that this set of requirements is considered as mandatory entry point for the next level of certification. The requirements drafted for level 2 are mainly inspired from common best practices and normative standards used in the certification of safety critical systems, whereby mainly techniques like fault tree analysis or failure mode analysis are used to challenge the requirement in search of potential flaws that may lead to hazardous situation, and where also a 100% code coverage is also recommended, even if formal methods are used. And if this percentage is not reached, then we have to provide justification for the uncovered execution path. For instance, it can be the case that the dead code is due to defensive programming or due to application configuration. It can be also that the uncovered code is due to hard to reach conditions, mainly when cryptographic functions are used. So, for level 2 certification, the requirements to be fulfilled by developers essentially cover 4 main aspects. Mainly the quality of the requirements and design specification document, the sufficiency of test objective to be covered and to ensure that all the different aspects of smart contract in terms of functionality, security, liveness, robustness, and efficiency have been covered, to check the quality of the test performed in terms of code coverage, repeatability, and auditability, and also to ensure the quality of the code itself in terms of readability and absence of any common security weaknesses. We'll consider all of these different points in more detail in the next topic. So when considering a DApp for level 2, it is expected that the developers must provide a specification and design document that satisfy a set of requirements. For instance, it is expected that the specification document must describe in a precise and unambiguous way the general architecture and interface of the app, the different correlation between the different components constituting the app, also including the smart contract parameters. The specification document must also clearly state the high-level properties to be satisfied by the smart contract, and these properties must be as complete as possible. And any assumption performed and set on interfacing component must also be documented. Mainly, it is required that those interfacing components should also have at least a level 2 certification. It is also expected by the designer to provide evidence that this functionality has been applied to challenge the specification, so as to guarantee the absence of design flaws or common security vulnerabilities. And finally, the developer must provide threat models, establishing the robustness of a smart contract against potential security attacks or against even off-chain code tampering. So all these, I would say, quality requirements are essential because there is a need to ensure that we are not validating an implementation against flawed specification. And a test specification document must also be provided to be eligible for level 2 audit. This document must clearly describe the test objectives, their traceability with the app requirement, and their associated test cases. Mainly, it is expected that a test objective must be specified for each requirement. The test cases specified for each test objectives has to be sufficient to cover all the possible execution paths within the cone of influence of the test objective. It is also recommended that avalanche and stress testing to be performed so as to assess the performance and robustness of a smart contract. Mainly, for instance, to show absence of contention issues or absence of a resistance against the DOS attack, for instance. And finally, the test specification document must clearly state the test environment, the tools, configuration used to execute the test and to compute test coverage. The designer is also expected to submit a test report for audit. This test report must clearly state the test result, whether all the test objectives and test criteria have been met. And we expect that this test report must provide an evaluation of the test coverage and test completion, such that the test coverage criteria must target 100% path coverage, and if this percentage is not reached, justification has to be provided for unreachable and uncovered path. The source code to be audited must also satisfy the set of requirements. It is expected, for instance, that the source code must be readable, understandable, and testable. Its size and complexity are well balanced. The source code is properly documented and traceable with a specification, and the developer also has to mention the development environment configuration as well as the compiler version used to produce the executable code. As for requirements relative to auditors, they explicitly state both the responsibilities and key competencies that each auditor eligible for level 2 has to fulfill. For instance, to guarantee the quality of the audit process, auditors are expected to carry out a set of tasks. For instance, they must acquire understanding of a smart contract logic. They must perform a thorough review of requirement specification to identify any inconsistency, safety or security flaws or incomplete requirements, to identify any implicit assumption, and to assess whether or not they are justifiable. We also have to review the threat model to guarantee that the mitigation that have been put in place are indeed appropriate against common security vulnerabilities. They must also assess the quality of a test objective and tests executed. And this activity mainly entails re-executing the test cases, auditing the test scripts used for automated testing, for instance, and verify the test coverage criteria. They must also perform code inspection, either via manual or automated means, to ensure that the source code is properly documented and traceable with the requirement, and to ensure that the source code is free from coding pattern or programming mistakes that can lead to exploitable vulnerabilities. And finally, auditors are expected to produce a detailed audit report, clearly stating their agreement or disagreement on the eligibility of a smart contract for level 2 certification. And they must also state any deviation, vulnerabilities found during the audit process, classify them according to an appropriate severity level, and provide, when possible, any recommendation on how to correct the identified defects. And to be eligible for level 2 certification, auditors must also provide the necessary credentials for a set of key competencies. For instance, they must have an in-depth knowledge of the syntax and semantic of a smart contract language to be audited, of the underlying blockchain technology, and of the associated gas computation model. They must be competent in the methodology used to elaborate the threat models, and to assess the consistency, correctness, and completeness of requirements. And it is also expected that they have competence in various tests and verification methods, and have solid background in various test coverage criteria. So, To summarize, the level 2 certification requirements have for main purpose to ensure the quality of requirements in terms of consistency, correctness, and completeness, to ensure that we are not validating implementation against flawed specification, to ensure the sufficiency of the test objective and properties, to make sure that they cover all the different aspects of the smart contracts, mainly in terms of functionality, robustness, security, liveness, and efficiency, to ensure that thorough testing has been performed on the smart contract, and that the test cases are repeatable, mainly for constant monitoring. And finally, to ensure the quality of the source code, in terms of absence of programming mistakes that can lead to security or even contention issues. So that's all for me. I hope that you have enjoyed this talk, and see you soon.
So, as you know, emphasis on security has been at the core of the design behind Cardano since its inception. And with Ouroboros, Cardano has designed and built the first provably secure proof-of-stake protocol in the blockchain world. And when it comes to Cardano's layer 1 infrastructure and the platform built around it, and I quote from the documentation, every significant proof presented in a white paper written to cover core infrastructure needs to be machine checked. And formal verification tools and methods such as SMT solvers and proof assistants like Isabel are applied to verify Haskell code so it correctly corresponds to our white papers. So with Alonso and smart contracts, we are inviting builders in our community to build an ecosystem of exciting new products and services on this secure infrastructure. However, this also brings with it a challenge of introducing vulnerabilities inherent in smart contracts in this emerging ecosystem. So in this session, we'll talk about how we are engaging the community in an attempt to extend the promise of security that's inherent to the Cardano platform to decentralized applications that are built on top of it as well. So today we invited a few bright people from the community who are involved in designing and implementing secure decentralized software for the Cardano ecosystem, in building tools that will help developers build secure applications, or that will provide services like security audits of dApps built on Cardano. So joining me in this discussion are John Hughes, professor at the Chalmers University at Gothenburg and founder of QuviQ, Duncan Coates, partner and Haskell consultant at Well-Types and lead technical architect here at Input Output, Wilhelm Sjoberg, formal verification researcher at CertiK, Victor Miraldo, research software engineer at Tweag, and Everett Hildenbrandt, Chief Technology Officer at Runtime Verification. So let me start by asking, what are the main security issues with distributed software systems, and more specifically, what are some of the hardest challenges that are introduced with distributed ledger and smart contracts technology in particular? And how do you think these challenges can be overcome when it comes to operation, implementation, and design of decentralized applications on blockchain?
Okay, so I guess I should start by trying to answer that. So as you said, I'm representing QuviQ here, and we are experts in property-based testing. I'm one of the inventors of QuickCheck. And that's really where we're coming from here, that we are looking at ways to test smart contracts, and in particular the on-chain code, as thoroughly as possible. So we're involved in the level 1 certification that is based on testing rather than formal proof. And we're really approaching this not as a way to catch malicious developers, but as a way to help honest ones follow best practices and avoid making the kind of mistakes that can very easily result in bugs and be exploited. So so that the kind of things that we're looking for are you testing the right properties of your contracts? One thing that can go wrong with contracts, which has I don't know if you'd call it a security problem, but it may be impossible to get all the funds out of a contract. Right? You can easily end up in a blocked state in which no funds can be recovered. So one of the things that we want to make sure we test is that no matter what happens as you're using a contract, there's always a way to recover the money. And that's a property that every certified contract ought to satisfy. So one question is, are you testing the right things? And another question is, are you testing thoroughly? And to test thoroughly enough, you really need to generate test cases. I can't emphasize that enough. When people write a test suite, no matter how large, it's inevitable that they focus on the happy paths. And when a system is tested that way, there are always bugs that may appear quite easily with generated tests. So our focus here is on generated tests, which among other things lets us vary tests to explore what happens, for example, if a transaction is dropped or maliciously blocked, or if a part of a transaction like a signature is dropped. Does that then lead to a reasonable result or not? So that's the kind of approach that we're taking.
So let me talk about let me answer the question, Nabesha. So I think, again, I'll start with kind of the context that we're coming at this from before I sort of say what, your question is about what are the challenges. But let me say the context again. So I am a great fan and advocate of property-based testing, and QuickCheck in particular, and I've been using QuickCheck for 20 years in all kinds of manner of different contexts, all kinds of different applications. And recently, as part of helping the team at IOHK build the new node, we've been using QuickCheck, comprehensively on every component in the system, basically, using lots of different techniques with QuickCheck. There's different ways of using QuickCheck. So that's the context that sort of, when it comes to sort of certification or auditing, the approach that we intend to take with auditing is I think it would fall into the category of kind of level 2, as was being described earlier, where we would be looking at, are people using, specifying their QuickCheck models in the right way? Are they testing the right things? Do their tests make sense? Are they covering the right things? So it would be building on exactly all the QuickCheck machinery that John and colleagues and other people have been building, and saying, are people using that in the right way? Are they covering the right things? How does the model that they've described correspond to their white paper? Or what's the correspondence? Looking at the evidence that people have laid out and checking that that evidence stacks up. But taking an opinionated approach of saying, you have to be doing it in this particular way. You have to be doing this kind of QuickCheck, property testing, model-based checking, model-based state machine-based modeling. So that's the sort of starting context. What is the biggest challenge I think that people will face in all this? I think it's figuring out what is it that their system is supposed to do. How do they express precisely what it is that they want to do? Many of us here have read many white papers from people who are building decentralized exchanges and all these sorts of things. And you start off with these high-level white papers, but you have to go down to the level of, well, this is what it means on-chain. This is what the on-chain interactions are. What are the properties of that level that tell you that, at a high level, you're doing what you wanted to do? How do you express what is it that you really wanted to do? So I think that's going to be the biggest challenge. And it's partly a technical and partly a non-technical challenge. And because it's non-technical, or partly non-technical, in many ways that makes it a bigger challenge, because it'll be about education and in how to think about things in a more formal way, which average typical developers have not had as their background. So I think that's going to be the biggest challenge that we face.
Yes, absolutely. So I guess blockchain in general is one of the most challenging areas, sort of by nature, because the whole point is that you put the trust into the contracts and the code rather than in manual processes and trusted people. So every possible vulnerability gets amplified, because by intent, there's no way to easily change it later. So speaking from CertiK, I guess this is really where formal verification and automated static analysis comes in, but also you really need a lot of human expertise to know what problems to look for. Like, we have a lot of manual auditing going on, and we're trying to build up a lot of knowledge about what are the typical problems that people run into, for instance, with these decentralized exchanges and so on. As one example of a challenge, I think one sort of novel thing about blockchain world is that there are new challenges all the time, but you can't update the old code. It's like we sort of saw this last year with the flash loan crisis. There was lots of these contracts that were probably sound when they were uploaded, but then the landscape changed on their flash loans and their model for how people are trading and how you can get prices from the market prices was no longer valid. So this is something that probably needs to be addressed by like going back and checking contracts again. We have some systems to like automatically rescan contracts, and generally you just need very careful analysis of what can now go wrong but did not go wrong 6 months ago.
Hey, yeah, so I mean, there's a lot of challenges and security issues in, verifying smart contracts, but I think the biggest one we've seen is that people and software developers just have bad mental models for these systems, so they don't have a good understanding of the system they're targeting, and somehow, if you switch from one ecosystem to another, even the way that transactions are executed is different, the way that contracts can call each other is different, and somehow they're bringing in all this context from some other language they're familiar with, and they just assume that all of that will kind of work the same for their smart contract development, but they have to kind of adjust their mental model to take into account these more low-level details about how the architecture actually works that they're targeting. Another example of this is, the traditional way of, building a library and releasing it as some sort of either statically or dynamically linked library that gets installed on people's systems, and you can just kind of assume that everyone has access to those. And even just that simple assumption that's kind of baked into how we've done software development for decades is not true anymore, right? So somehow you have to adjust your mental model, and then also help the clients adjust their mental models, because the assumptions that are kind of baked into how we do software development are not always true here. Another simple example is just, anything to do with integer arithmetic, complex arithmetic. People usually think, oh, okay, a little bit of rounding error. It's okay if it rounds down, okay if it rounds up, or something like that. But when you're actually talking about managing money, it becomes important to actually quantify rounding error bounds and stuff like that. Most programmers aren't used to dealing with things like that. So there's a lot of kind of mental model shifts people have to make to have a more accurate idea of the system they're targeting, and also how to kind of code defensively against that. And this is really amplified by something John mentioned, which is this, that people test the happy paths. Well, people only think about the happy paths too, right? They think about, oh man, my system is going to be amazing when it's operating like this and this and this, and everything's going to be balanced, and all the, whatever's going to be stable. They're going to have all those ideas in their head, and then you throw one little wrench into it, one little negative test case, call a transaction wrong, something, and suddenly the whole system goes haywire. So somehow you didn't have the stability you were hoping for of your system. So
great, thanks for your insights. So the next question is, so proving that security and desired properties of complex system hold under most imaginable real world, and in particular under most adversarial conditions, can be extremely effort intensive and time consuming. So how do you approach security audits of decentralized applications in your daily business? And what tools are you building or using to better manage this workload? And how do you strike a balance between required effort and exposing and addressing all relevant vulnerabilities in the project that you are auditing? So basically, what's the right mix of manual work and automation when it comes to DEP audits and certification?
Okay, I guess I should start by saying to that. So I want to begin by referring back to what other people have been talking about in the major challenges. And certainly, I think one of the big challenges here, particularly for the level 1 automated phase of certification, is that we're supposed to certify code. We don't know what it's supposed to do. And this is a classic problem in any software testing. It's called the Oracle problem, that you need to know when a test has failed. And to do that, you need to know what the system is supposed to be doing. And our experience with using property-based testing with many customers over the years is that indeed, people have only thought about the happy path. So when you come to them with a test case that you generated and they say, well, what should it do in this case? Developers very often don't know. So getting specifications that apply in all cases in complex contracts, that's going to be a major challenge, and it has to cover not only functional aspects but non-functional aspects, such as if you put a secret on the blockchain and it's not encrypted, then you've lost, right? So certification should really check that whenever secrets go onto the blockchain, they are encrypted. But to check that, we have to know which are the secrets. What information is supposed to be secret, because some might be supposed to be public. So unless developers are able to express their intentions in a way that is then checkable, and unless they do that, then it's not possible to check that kind of property. So one of the things that we've been working on just in the last week or two is annotating secrets in the types, so that we can take advantage of a lot of research that's been done over the years on type systems that guarantee that secrets don't flow to the wrong place. And in this case, the wrong place is the blockchain, of course, or in plain text in a transaction that's going to go out onto the network. So that's one way of approaching the security problems that we're looking at. I think another problem in testing contracts of this sort is that when a contract submits a set of transactions to the blockchain, any subset might be committed. And that means, and the others just might be rejected. I mean, maybe the user decides not to submit them or something. So that you really get a state space explosion there, unless contracts are very careful to control that by waiting in the right places for transactions to be confirmed. And I think we're facing a kind of distributed concurrent programming problem, which always makes any kind of testing or verification rather more difficult. And that's one thing that has to be kept under control for contracts to be well tested and for us to be confident that they work well.
Okay, so the question was around automating some aspects of the testing for security for devs that are undergoing security audits. So how do you balance between the effort and the time required to do all the manual checks that are required with automating some of these tasks and making sure that we can actually manage the bulk of the applications that are coming our way now that that we are opening up the platform for application development.
So the approach I think that we have to this is to say, in our experience, quick check and this kind of property-based and generating random inputs in a systematic random way, this kind of approach can be extremely good for being pretty comprehensive at testing systems, and we think the same will work with. I mean, it's difficult, as John has described. There's lots of challenges in it, but we think that's really, the kind of sweet spot of, quality of coverage and practicality of doing it. We think, based on years of experience, this kind of quick check approach is a really good sweet spot in getting really pretty good comprehensive automated testing at a in a very practical way, and that's really important because building these systems is hard, and you need to be able to do this in a practical way. So I think what's the balance between automation and manual? The way that we are approaching it is to say all you're really doing it manually, hopefully, is just checking that you've done the right things in an automated way, right? In other words, you've written the right quick check tests that check the right properties, and that makes sense, and that those properties make sense against your high level or your mid level white papers or your mid level more detailed technical designs. So we don't want to be auditing manually tricky properties. We want to be using the techniques and tools that John and colleagues and other people are developing, and that those are the recommended standard practices for all Pleasure developers. We want to say do that standard thing and do it to a high level, and then the manual checking in the auditing is really reviewing that the evidence that you've collected is right, that it makes sense, that you've laid everything out in the right way, you've done all the right tests, your generators are good, etc., etc. That's the way we see as a kind of really good practical balance of use as much automated as you can, and then manually checking that you're doing the right thing, doing the right automated tests.
Okay, so I can talk a bit about how we do it at CertiK. So we also use a lot of automated tools, but we do have a heavy manual component as well, and I think that's kind of unavoidable in some sense. So like typically what we get as input is not just the code base, but also the white paper for like the smart contracts that we are supposed to audit. And auditing the white paper itself is also like an important component. Like for instance, we have trained mathematicians and economists. So like in appropriate cases, they will sit down and do like a pen and paper analysis of the economic model assumed by the contract. And as I said before, like our auditors typically deal with the same type of contracts a lot. So they get a sense of what kind of problems to look for in them. And then, of course, we try to automate as much as possible. So we have like a big suite of different automated tools that can run on it, which goes all the way across the spectrum from linters, static analysis and simple tests, but also some mul checking, some SMT-based things. And generally, and those can also be helpful. Like a subset of those can be run automatically and sort of automatically populate the security leaderboard with some preliminary information. But for the full audit, we are still aiming to automate as much as possible, but not more. So I guess one of the key points of CertiK's philosophy here is that we want to leverage the fact that we are doing a lot of audits of different contracts. So we can see what classes of vulnerabilities arise often, and then we can develop specific tools to find those, and then we can like gradually generalize and automate more and more of the process so that we can like check more and more classes of problems completely automatically. But also this automation can also be leveraged to help manual auditing. So for instance, if you find a particular snippet of the code that was associated with a bug in one contract, then we can put that into our database, and then we can automatically highlight like similar snippets of code in other contracts that come in and like draw the auditor's attention to it. And then they need to do some manual thinking to figure out, is this actually a vulnerability in this situation or not? So we're trying to automate as much of the manual auditor's work as possible, but we still think there needs to be a human in the loop.
Hey, yeah, kind of mirroring what the others have said. We also, have a mix of manual and mechanized formal verification. But at RV we take a verification-based approach or verification-oriented approach to auditing rather than kind of a testing-oriented approach, which is something that has kind of confused some clients, but it's just something you have to explain to them. We're going to actually try to prove that your code is correct and then find counterexamples along the way. And I don't think we've had any engagements where we haven't found counterexamples using that technique. But the usual technique we use is we'll build a formal model of the system just on paper and kind of go back and forth with the client to make sure that we've accurately captured their intention, and then also that it's actually a mathematically rigorous model that we can work with. Because usually they have some sort of white paper or something like that. It's somehow a specification of their mental model of the system, but it's not really a formal model. And we also sometimes build executable models depending on the context. So these actually can be in whatever language, but they even just transliterating the code into another language, often you catch kind of hidden assumptions that the code is making. And then we'll verify by hand that the code actually implements whatever model it is that we produce, that formal model. So this part of the proof, we sometimes mechanize this refinement part of the proof, that somehow our more abstract representation of the system is actually refined by the code. Our tool K is able to show these functional correctness properties that can show, basically some sort of subsumption of the transition systems. And yeah, so like I mentioned, K is the tool we work with. It's it's an operational semantics framework. Where it's really strong is in verifying and summarizing the behavior of low-level code that we have semantics for, basically. So that's what we use it to do, is to come up with kind of closed form symbolic summaries of the code, and then we can work from those symbolic summaries instead of having to look at the code itself when trying to argue that there's somehow refinement between our formal model and the code. And then finally, we have to identify with the client some important properties to hold over the code. Usually these are simple economic properties, but they usually can be expressed as invariants or as just bounds on certain quantities, and then sometimes some sort of non-deadlock property or some other more complicated liveness property. And then we just verify by hand, once again, that our model has those properties. And then finally, the last part of the audit is, we have a curated checklist of these are things you should check in general, and these are things you should check for this specific ecosystem. So we have a list for Cardano, and we have a list for other ecosystems as well. So that's kind of the overall process.
Okay, thank you. So as I mentioned also at the start, Cardano is the project that's, together with the Plutus platform, it's based on some pretty novel technology, even in the highly innovative blockchain and crypto worlds. So, especially like with its extended UTXO accounting model, application of formal methods, and also Haskell as a choice of its smart contracts programming language. So do you see any specific new challenges arising or new opportunities that are opened up when it comes to security, reliability, and availability in the application layer that are specific to Plutus and Cardano as a platform that you might not see elsewhere in the blockchain world? And how can these challenges be addressed, and how can we take advantage of any opportunities coming our way?
So I think, of course, the fact that the on-chain code is in a strongly typed programming language with a powerful type system, right there, that eliminates many possibilities for security violations and errors. And that's a huge... Every piece of code on the blockchain has been through a kind of rigorous static check before it's even deployed. And that is, I think, a great opportunity. Also, the UTXO model, the programming model, seems to keep things simple and make some attacks impossible. If you compare it to the Ethereum blockchain, the fact that sending any payment may invoke attackers' code really poses fundamental problems for writing secure contracts. And that was a key part of the early DAO infamous hack that stole $60 million worth of Ether at that time. So I think the way that the Cardano blockchain and the Plutus language have been designed gives good preconditions for developing contracts that are secure. Many of the problems that other people have to worry about are not going to be problems for Cardano.
Yeah, so I agree with John, basically. I think, both, I particularly want to emphasize, I think the UTXO design of the ledger, if you compare it to, the obvious comparison here is Ethereum. And well, I remember when RV was doing some work previously on the EVM, trying to model that in K. The EVM is extremely complicated, and just the sort of it's very, very low level, and just the kind of number of things you can do and state changes that can happen. Whereas in the UTXO model, extended UTXO model, it's just a much higher level model. Like the level of what can actually happen is at the level of this graph, which is suddenly this just much higher level. So the kind of number of interactions and things that can happen is just substantially reduced. So I think that puts us in a much better position for the sort of tractability of analyzing what's going on, just the sort of complexity of what could potentially happen is just dramatically reduced. So I think that in itself puts us in a very good position. And yeah, I mean, the fact that we're able to do this at a slightly higher level means that, okay. The other big thing I think is the fact that the Plutus authors and have been really pushing people in the direction of a particular model of doing things, which is this state machine model, which I think is a very nice way of it's very expressive, but it's also again another high level design, high level model, where I think again that makes it easier to do testing and to write properties and to think about what are the possible interactions and reduce the state space and the complexity of what's going on. So I think those two things, the underlying UTXO model and then the standard pattern of a state machine, I think puts us in it's a great opportunity, I think, for being able to do things in an easier way, which then I think makes this kind of quick check testing approach a very practical way of getting really pretty good assurance of what's going on, that your contract does what you think it's supposed to do.
Yes, so I agree with both previous speakers. First, the general approach of, I guess, Cardano and Plutus has the experience of Ethereum to look at to know what not to do. So they were able to develop a model that can avoid some of the problems that have shown up in the past. And the second key thing, I think, or the second interesting thing is that the contract programming language Plutus is like a Haskell variant as opposed to Solidity, which is dominant in the Ethereum world. So I think Victor was saying before that formal verification is a spectrum, and using Haskell can help on various points of the spectrum. So first at the most basic level, like John said, it's a good language to write careful programs in. You have the type system that helps you enforce invariants. You have a good testing infrastructure, quick check in particular, and you can use the type system to define good APIs for the system libraries, and then guide the application developers to do that. So at the most basic level, I think it's a solid choice of a language. And then at the most advanced, I think it's also quite interesting and exciting that Haskell interprets very well with very advanced theorem provers. So if you want to go all the way and do full functional verification, then in that space, all the big theorem provers Coq, Agda, Lean, Isabelle Hall, all of those are based around a pure functional programming language at their core. So using Haskell, it's very convenient to interface with them. You can use program extraction, or you can use tools like HS the Coq to directly connect your code to the proof assistant. So I think this choice might actually put Cardano in a good position as the industry matures a bit and people do more and more advanced functional verification, because it's already in the sweet spot for that. Then I guess you also asked about challenges, and I think maybe the biggest problem is that it's all new. So in particular, at the middle of the spectrum, where you have not full functional verification, but various automated tools to check static properties. I feel Haskell does not have that much compared to some bigger languages in the world, and in particular Plutus, as a subset of Haskell, doesn't yet have very much tooling. So there will be an interval while we're all developing this tooling. And I think also because the model is different, this will take us into sort of a new territory. So the UTXO model is different from the account model. So for instance, there was a lot of decentralized finance contracts written in the Ethereum world, and then people have been porting those more or less literally to various other chains, and those contracts are doing exactly the same thing. So they have exactly the same security vulnerabilities. But if we want to port them to Cardano, then probably the performance characteristics of UTXO means that they need to be tweaked a bit and done in a different way. And so I think generally we have less experience with what the problems are. I think if you look back at Ethereum, there's always been new problems being discovered. Back in 2016, people suddenly realized that reentrancy was an issue. nowadays it's easy to avoid, but back then people didn't even see it coming. And like the flash loan crisis last year is kind of the same thing again. Like now we know what to look for, but like it was a novel thing. So I think the fact that we don't have that much experience in the Plutus world is a challenge that sort of pushes more onus on us to do a better job at like really checking everything very carefully, because we don't have very much history to lean on.
Yeah, absolutely. I do agree. I do think it was a great summary of challenges and opportunities. I would like to expand on one challenge / opportunity that both William and Duncan brought up, and I'm particularly interested in that, which is precisely the novelty that the extended UTXO model brings, right? We are building, IOHK is building this massively parallel infrastructure. But as Duncan pointed out, we are still relying on a state machine model of doing things, which I think it's a great model. We are familiar with it. We know how to handle it, and we can program with this model. But would be very interesting to also understand which other models could we be using to take benefit of this massive parallelism and this massive concurrency that we could achieve, because I think that we can achieve unmatched performance with the extended UTXO model if we choose the right underlying framework, not only to implement but also to reason about this. Because whenever we use state machines, we can reason about it with familiar techniques, but this also means often applying the very heavy hammer of linear temporal logic, which is a complex tool to use. And perhaps if we could find a more denotational model, for example, for what these constructs are and what are their actions on this graph of the UTXO, this could be very interesting. And I see this as both a challenge and an opportunity. A challenge because we need to sit and do this research and understand which other ways are there to do things, and an opportunity because it's really fun to do, and I hope we get the time and the resources to do it.
I think all the points that have been made are really good. I want to go back to the idea of this mental model that developers have in their head for when they're, developing smart contracts, and somehow the UTXO model is not in the normal, developers model. So I think that's one challenge, is just an education challenge, honestly, so that people understand better what's going on with the UTXO model, and then are able to, program accordingly, basically, with that in mind, because somehow, different operations have different efficiencies, and so you have to adjust the way that you're writing your code. And oftentimes, when a client comes to us, they come to us with an optimized version of the code, and it's been optimized, targeting their specific platform, and somehow extracting a model from the optimized version means first de-optimizing their code and then extracting the model. And those optimizations are always going to be specific to whatever platform it is that you're targeting. So in this case, the UTXO platform. I think the other really big challenge for the Cardano and Plutus ecosystems right now is just the tooling problem, which is going to be a problem for any new programming language or any new blockchain ecosystem. So Ethereum's been around a while and has a lot of tooling available for users, and I don't just mean formal verification tooling. I mean, all sorts of tooling. So IDE support and developer environments, testing environments, like think of Truffle, stuff like this. All of these things people are kind of used to in the blockchain ecosystem. And, when people think, oh, okay, I want to target and make a new app on this new blockchain, they think, what's the equivalent of Truffle on that new blockchain? And so somehow, there's just even the basic tooling that people need to be able to develop effectively needs to be developed. That's one thing we try to address with our K-based approach, is we make the formal, a faithful formal semantics of the programming language, and we test the faithfulness of our semantics by running the same test suites as other clients, and we even have examples where our VM is kind of the default VM integrated into clients. But then using that same semantics, so that they agree, we also offer a formal verification engine, basically, so that you can have high assurance that the model that you're being verified against is the same as the one that was being that was tested for conformance with the other clients, basically, which is basically the best you can hope for, because we're not about to take all these different formal models and show their equivalence to each other, because that's a huge government sponsored level type of project. And then another tool that we try to derive automatically for each of our semantics is a symbolic property testing tool. We mostly use that internally, but it basically exposes primitives that allow users to write symbolic property tests in language X, in this case Plutus, although we haven't developed a Plutus semantics yet. And then you can write your symbolic property tests in that way. So for me, the biggest challenges are, once again, the shift in the mental model, which, as the previous speakers have said, that's actually, the UTXO mental model is actually a huge benefit, and also these stronger type systems are a huge benefit, but somehow you still need to educate people and get them to make that mental shift. And then just the lack of tooling, which is obviously an opportunity for all of us here, because we're all developing tooling targeting these ecosystems.
Can I just follow up and agree with Everett about the mental model? I think he's absolutely right about that. And I've seen the same thing where, people come to us with here's our description, here's our white paper, and here's our, kind of lower level description of what we think the system ought to do. And it's all couched in terms of the mental model is clearly the Ethereum EVM model, right? It's all methods that do this, do that make state changes. And yes, okay, that has been the, up till recently, smart contracts has always meant Ethereum, because they were the first ones to do it. But the market of people who are writing smart contracts is much bigger than, or potentially much bigger than what the people doing it right now. So yes, we now might need some stuff for retraining people who were used to thinking one way into thinking another. But I think also we need to just have good training materials, tutorials, courses, etc., on how to think in terms of the UTXO model just from straight, because the vast majority of people coming in having never written this stuff before. And it does need, I think you do need to internalize that model before you can really see how to translate your ideas about what you want to do into objects in the domain of the system. Unless you're doing something awesome like using Marlowe, then if you're doing it at the level of Plutus, you do have to think, I think, about these issues of, well, what are my tokens, what are my addresses, what are my scripts, what are my transactions? You have to map it down to this UTXO model, and that needs.
Okay, thanks a lot for your thoughts. I actually had a couple of other questions prepared, for example, around formal verification and what we can do to help the developer community, both in the design phases of their applications, as well as best practices and guidelines on how they can prepare for the audit and pass the certification with greater certainty. But this is easily a topic that we could extend to another couple of hours, but we have limited time, unfortunately, for this discussion. So let me just wrap up by asking you your quick final thoughts on if you have any advice or guidelines for the developers that want to submit their applications for a security audit or for application certification, what would those be? And are you engaging the Cardano developer community already in collaborating with them in building out the ecosystem and the tooling and understanding their needs going forward in growing the ecosystem of decentralized applications on Cardano?
So I think developing property-based tests is a very good start, because the key thing when you develop property-based tests is you need to develop the specification. At whatever stage of the audit you're going through, you're going to need to know what specifications are. So especially for people who are focusing more on writing unit tests, I would say develop property-based tests instead, and look at the contract model framework that is now a part of the Plutus development ecosystem, because that makes it quite easy to do. So there is work there, which is a very good preparation, I believe, for every stage of the audit to come.
Yeah, so similarly, the advice that I would give is use the standard tools that are available. Use the the state machine model the Plutus teams advise, the documentation advises. Use the quick check tooling that's available. Think about the evidence that you are presenting, before you come to audit. That you need to see what is the relationship between your white paper, your intermediate level technical description of your design, how that maps to your quick check state machine model, and what properties need to be there. Think about all those things. Think about what that evidence is. Lay it all out. And I think if you can do that, auditing is just a matter of checking that that people agree with you that is the good evidence. So you need to be thinking in terms of use the standard tools, use the stuff that's recommended and given, and think about what evidence you're presenting to the community, in addition to
Yes, I can just echo what everyone else is saying. The more work you do up front, the smoother it will be to check that it's correct. So be very careful about spelling out what your assumptions are, what the requirements are, and document how the code is meant to work, and write tests.
I guess that's a great summary. To add to that, also think about your adversaries. In any security scenario, you're always defending against something, and be sure to specify what that something or that someone can do. That's part of a good spec in this space.
Yeah, what people have been saying is great. I like to tell clients and kind of discourage this idea of kind of passing a security audit or something like that. Instead, the audit process should be almost continuous. And you should have your own internal audit process, someone checking over and making sure that everything is kind of making sense. And ideally producing the specifications as needed, because at the end of the day, as John was saying and emphasizing, thinking about and building specifications is absolutely always the first step when you're trying to check, does the system do what I want? Because you have to first say what it is that you want, right? So somehow, this emphasis on specification needs to be improved, and people need to contact audit firms early, and maybe even when they're just in their design and ideation phases, so that it becomes more of a design consulting sort of engagement rather than a design review or design audit. And then another point that someone made is this, this idea of presenting evidence to the community, right? And that's also how I word it for the audits we produce for clients. Is we're presenting evidence to the client that things are okay. We're presenting evidence to the client in the form of counterexamples, for example, right? So somehow we have to convince the client, because even if you do formal verification, if you're the only one who understands that formal verification you've done, it's not going to convince anyone. And somehow there's this social component where you need to, be convincing with your evidence that what you've done is enough, quote unquote. So, yeah, I think people need to shift away from thinking, okay, security audit is that bar that I get past, to more this mental model of I'm always gathering evidence for why our development practices and our artifacts, the code we produce, is actually safe.
Okay, well, thank you everyone for joining me for this session today. And it's going to be a kind of fascinating journey to see how the whole ecosystem of all of the tooling and services around application certification, and making sure we are kind of extending this promise of a secure platform also to the applications built on top of it, and how this is all going to pan out. I think it's going to be really exciting. So thanks all for participating, and looking forward to be on the front lines of working on this subject with all of you going forward. Thank you.